Hi, in this video, we will use law of sines to help us to solve non-right triangles. Okay. First, let us try to see if we could find the area of the triangles. Okay. So if we have a triangles, okay, then if I add a height, okay, which is perpendicular to C, okay, if we do this, then of course we know that the area of the triangle is equal to 1/2 C times H then. Right? Okay. And now let us try to look at this triangle right here. Okay. So to these triangles, then we have the height is H. And then this angle right here is the angle A. And then we also have the angle B. Okay. Now, to these triangles, we will not be able to write this side right here because we don't know what it is. It's not C, right? Okay. It's a distance shorter than C, but we don't know what it is. Okay. So then now, based on these triangles, okay, then we have the angle A. We have the opposite of A is H, and we also have the hypotenuse. Okay. So then let's see how we can relate these three measurements, the angle A, H, and B together. Of course, in this case, we could use sine of A is equal to H over B then. Okay. In other words, then H is equal to B times sine of A. Okay. So if we replace H with B times sine of A, then we have the area equal to 1/2 C times B times sine of A. Okay. Okay, so let's check it out. Okay. Maybe let me rewrite this into 1/2 B times C sine of A. Okay. Okay. So let's see what information do we have. Okay. To find the area of the triangles. Okay. Okay. First, we have the angle A, and we have the sine B, and also the sine C, where side B and C is adjacent to the angle A. Okay. So if we have these three informations, we will be able to find the area of the triangles. Okay. 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 Then now, if I want to find the area of the triangles, okay, so of course, first, I could use the 1/2 B times C of sine of A, okay, to find it. Or, okay, if I want to use the, again, if I want to use the angle C to help me to find the area of the triangles, then in this case, what I can use is I could use the two adjacent side, which is A and B then. Okay. Then now it is 1/2 A times B sine of C. Okay. If I want to use the angle B to help me to find the area of the triangles, okay, Then in this case, if this is the angle B here, then the two adjacent will be A and C then, right? Then it will equal to 1/2 AC sine of B. Okay. Okay. Now, if I have the triangle A, B, C, okay, then in this case, we have 3 ways to find the area of the triangles. Okay. And now think about this. What if I divide everything by 1/2 ABC? Okay. Can I do this? Of course, because they are the same area. And then I divide by the same quantity, right? 1/2 ABC. So meaning the quantity of them remain the same. And let's see, 1/2 and 1/2 cancel. B and C cancel. Okay, so to the first term, or maybe I have this ratio over here, is sine of A over A. Okay. Let us look at the middle term then. Okay, so I have 1/2 and 1/2 cancel. So A and B cancel. So now I have sine of C over C. Now, then let's see the last term. I have 1/2 and 1/2 cancel. A and C cancel. So I have sine of B over B. Okay. You will see that now we have this ratio right here. We have a name to this ratio. We call this the law of sine. Okay. Then since this is a ratio, then sine of A over A equal to sine of B over B equal to sine of C over C. Or we could say that is A over sine of A equal to B over sine of B equal to C over sine of C. Okay. Okay. Note, the law of sine is useful when we know a sine and the angle opposite it. The reason is we could actually, again, probably set it up, right? The ratio, and then we could use this ratio right here to help us to find the missing measurement then. So then in this case, you will see that we could use the law of sine, okay, to solve the triangle with A as A, okay. The reason is, once we have these two angles right here, we will be able to find this missing angle, okay, missing measurement. Because again, the sum of 3 angles of a triangle must be 180, right? So we could actually find this angle. Once we have this angle, and then with this side right here, we could set it up, the law of sine. And then once we have the ratio here, then we could use this angle right here to help us to find this side. And then use this angle to find this side, okay? How about if I have SAA, okay? So same idea, then I could use this pair right here to set up, to use law of sine to set it up. And then we could use this angle to help us to find this side. And then, of course, we know this angle, and then we could use this angle to help us to find this side then. How about SSA? Same thing. We will be able to using this pair right here to help us to set up the law of sine, and then use this side right here to help us to find this angle. Once we have this angle, then we will be able to find this angle. Then we use this angle to help us to find this side. Okay. Okay. However, when you have the problem with SSA, then sometimes we may end up with some cases that we may not be able to find to solve these triangles because one of the side is just too short. Okay. You may have a right triangle. You may end up with two triangles, okay? Now, the reason why we have two triangles is because we don't know this side right here, okay? This length. What if the triangle that you have, okay, is not, that means it's not this triangle right here, okay, but this one right here, okay. So in this case, this is also the same side as this one right here, right? So therefore, if we have SSA, then we may end up with one triangles. Maybe we have two triangles, okay? Or we will have, again, this is not a triangle because, again, this side too short, okay? Okay. And now, let us try to work on an example now, okay? Now, first of all, if you want to, again, to solve the triangles, what we need to do is we need to set it up, the triangle first, okay? And then let's see how we actually set it up, the triangles. Because to the given problem, to this given problem, we only know the side B and side C, and then the angle B, right? Okay, so let's see. How do we actually set up the triangles, okay? Okay. Now you see that when we try to set up the triangles, one thing about this one right here is, to this angle A, the opposite side is side A. To this angle B, the opposite side is side B. To this angle C, the opposite side is side C then, okay? Okay. Once we know this, then now, let's see how we draw this, okay? So, to these triangles right here, then, again, we just randomly draw a triangle first, okay? Okay. Then now, if this is, again, if this is side B, or maybe this is the angle B, which is 40 degree, okay? If this is the angle B, then of course this side right here must be the length B, right? Which is 4, okay? And then now, then if I say that, oh, if this is 3 right here, then of course this angle right here must be the angle C then. If this is the case, then mean this one right here must be the angle A, and then this length right here must be the length A, okay? Okay. Then now, let's see how do we actually work it out, this problem then, okay? Then, how do we actually set it up? So right now, we have, okay, again, to use the law of sine right here, what is the first pair that we would like to set it up? Of course, I would like to use my angle B to help me to set it up first, okay? So I could have the sine of B, sine of 40 degree, divided by 4 is equal to, okay. Then now, to this one right here, we could actually set it up, sine of C over 3, and also sine of A over A, okay? Then, of course, first, we would like to use this equation right here to help us to find the angle C first, right? So then now, okay, if this is the case, then maybe we could using sine of C over 3 equal to sine of 40 degree over 4. Okay. And then now, sine of C equal to 3 times sine of 40 degree divided by 4. And C will be, again, we could use the inverse, right? The sine inverse of 3 sine of 40 degree over 4. Okay. Then now, what we could do is we could use calculator to help us to find the answer then. Now, let us turn on okay, turn on our calculator, and then we would like to input, okay? Now, first of all, make sure that the mode of your calculator is changed to degree. Okay. And then now input sine inverse of 3 times sine of 40 degree divided by 4. And you will find out the answer that we have is 28.8220. Maybe let us round it to 4 decimal places. Okay. Okay. So then it is equal to 28.8220 degree. Okay, so this will be my angle C here. Okay. And then once we have the angle C, then we will be able to find the angle A then, right? So we know that angle A is equal to 180 degree minus 40 degree minus 28.8220 degree. And it is equal to 111.1780 degree. Okay. Okay. Then now, once we know the angle A, then of course we will be able to find A then. Okay. Then we could have A over sine of 111.1780 degree is equal to, again, to this one, we could use the ratio B and the angle B. Okay. And now A equal to 4 times sine of 111.1780 divided by sine of 40 degree. Okay. And your calculator will tell you that A is equal to 5.802617. Okay. So I round the angle to 4 decimal places, and then I round the length to 6 decimal places, okay, to make it more accurate. Then after we've solved this, solve the triangles, then the next thing is we would like to find the area of the triangles. Okay, so then how do we find the area? Okay, so so in this case, we could use, okay, so again, we could use this, the area of the triangle, we could use this 3 right here, 40 degree right here, and the values, the length A, okay? So which is 1/2. 3 times 5.802617 and sine of 40 degree, okay? So then in this case, we could again use the calculator to help us to find the answer then. Okay, so 1/2 multiplied to 3 multiplied to 5.802617 and multiply to sine of 40 degree. Then you find out that the answer that you have is 5.594775, right? Or maybe let us round it to 4 decimal places then. So it is 5.5948, okay? Then let's make the summary. So A equal to 5.8026. Angle A is 111.18 degree. Angle C 28.82 degrees. And the area is equal to 5.5948. Okay. So then again to the angle, let's round it to 2 decimal places. The measurement of length and the area round it to 4 decimal places. Okay. Of course, you know that the more digits actually is make it more accurate, right? Okay. Oh, by the way, there's a rule of thumb. If you want to make that's mean the accuracy to 2 decimal places, during the process, most of the time we would like to use round it to 4 decimal places to get the accuracy to 2 decimal places. If we want to have the accuracy is 4 decimal places, then we would like to round it to like 6 decimal places during the process to work it out the problem. Okay. Okay, so now it is your turn. Now go ahead and try the next example. Okay. Okay, so now then let us again sketch the triangle now. So I have 2 and then this is 40 degree. And now I have this is 3. Then this angle right here will be the angle C here. Okay. Then again, this will be my angle A. This is the side A right here. Then now I would like to find the angle C first. Then I will have sine of C over 3 equal to sine of 40 degree over 2. And the angle C will be the sine inverse of 3 times sine of 40 degree divided by 2 then. Okay. Then if you use your calculator, then you will find out that the angle C is 74.6186 degree. Okay. And now we would like to find the angle A. So angle A is 180 minus 40 degree minus 74.6186 degree. And you find out that the angle A is 65.3814 degree. Okay. Then now we could use the angle A to help us to find psi A now. So A over psi of 65.3814 degree equal to 2 over psi of 40 degree. Okay. Then I will have A equal to 2 times psi of 65.3814 degrees divided by psi of 40 degree then. Okay. And your answer is 2.828620. Okay. And the area is 1/2. Okay. And now, again, we would like to use this angle 40 degree, this 3, and psi A to help us to find the area of the triangles then. 3 times 2.828620 multiplied to psi of 40 degree. Okay. And the area is equal to 2.7273. Okay. Okay. And now I have A equal to 2.8286. I have angle A 65.38. Angle C is 74.62 degree. And the area is 2.7273. Okay. Okay. Then now, let us look at this example here. Now you will see that this example right here is what type of triangles we have. We have side angle, right? So this one will be SSA. Okay. Now remember when I mentioned this, if you have the case is SSA, then what happened? You may have one triangle, and then the problem that we already found out one triangle. Is there two triangles, two solutions? Okay. Or something else. Okay. Now, how do I know that we are going to end up with two triangles? Or why do we have two triangles? Okay. The reason is when we try to find the inverse, okay, when you work with the inverse, the sine inverse, okay, essentially we will have, maybe let us do an example then, okay. So if I want to find sine of an angle equal to maybe 1/2, okay. So in this case, because sine of theta is positive, so meaning the theta is in quadrant 1 and 2 then, okay. So then quadrant 1 and quadrant 2, okay. So in this case, meaning I have this angle right here, And I also have this angle right here. Okay. And now we know that the reference angle, the theta bar. So in this case, we have theta bar. If we said sine of theta bar is 1/2, then theta bar is sine inverse of 1/2, which is 30 degrees. Okay. Okay. So then in this case, now of course, the first angle, it will be 30 degrees. This angle right here is the one that you get it from the calculator. Okay. Or we use the table. However, you also have the angle is in quadrant 2, isn't it? Okay. So in this case, meaning sine of 30 degrees equal to sine of 150 degrees, which is equal to 1/2. So when you try to solve for the inverse, okay, using inverse of sine to solve the problem, basically this answer, okay, the angle that I have is actually is you will have one is in quadrant 1, another one will be in quadrant 2. Okay. Now you will notice with these two angles right here, they're both less than 180 degrees. Okay. So then let's try this. Okay. Again, to SSA, you always assume that you have two triangles. How do I assume this? Okay. What I will do is actually is I will say that, oh, I have the triangle 1. Okay. Now this triangle 1 is we would like to work with the angle B sub 1 is 40 degrees. This is the given. Okay. So the angle B is always 40 degrees. And then now for the angle C, which is 74.61 x6. And we're using this angle C sub 1 to help us to find the angle A sub 1. Okay, so then the answer that I have is 65.3814 degrees. Okay, so so we have this angle A is 65.38. We have this angle is 40 degrees. This is 2 right here. And of course, with this angle A, we also have a side A, which is 2.82x6. Okay, and we also have this pair right here. This angle is 74.61. 60. And this is 3 right here. Okay. Okay, then now let us try to work with the triangle number 2 now. Okay, so to this triangle, again, my B sub 1 is the same. Okay. But in this case, my C sub 1, oh, I'm sorry, C sub 2 now, right? Because we are working with the triangle C sub 2 here. It will be 180 degrees minus 74.61 x6 degree. Okay, again, why do we have these solutions? Because when we work with the sine, again, when we try to solve the sine of an angle equal to a number, okay, if this number is positive, we have the angle is in quadrant 1 and then quadrant 2. Okay, and how do we got the second angles? In quadrant 2, we're using 180 subtract the number that you find it from the calculator, right? Okay. So then, in this case right here, we will find out that the angle C sub 2 is 105.3814. Okay. And then now you will see that the sum of B sub 2 and C sub 2 is actually less than 180. What does this mean? It means that I will be able to find my angle A sub 2 now. So I'm using 180 minus 40 degree minus 105.3814. Okay. So which is 34.6186. Okay. Then now, in this case, what does this end up? So again, we have these three right here. Okay. This is the sine. Oh, maybe let me. This is the side C with the angle. This angle right here is 105.3814. Okay. And this angle right here is still 40 degree, and this is 2. Okay. Then now, this angle A right here is 34.6186 then. Okay. And of course, with this setup, we will have a different A values. Okay. So let's see. So in this case, A over sine of 34.6186 is equal to 2 over sine of 40 degree okay. And then we find out that A is equal to 1.7676. Okay. This is exactly what happened here. So therefore, in this case, we will have, again, to this problem, we have two triangles. Okay. And to the second triangles, okay, is we have A is equal to 1.7676. We have angle A is 34.62 degree. We have the angle C is 105.38. Okay. Of course, to both triangles, we have A, oh, we have B equal to 2, and then C equal to 3. Right? Okay. So of course, to this triangle right here, your area will be, again, will be a difference as well. Okay. Okay, then let's check. How about the first, that's mean the example number 2. Okay. So again, let's check it out. This one right here is also is as a, okay, side angle, right? It's also a side angle. Meaning, in this case right here, again, we need to set it up a triangle 1 and triangle 2. Okay. Okay. So to the triangle 1, we actually have an angle B sub 1 is 40 degree. The angle C sub 1 is 28.8220. And then based on this, we find out that the angle A sub 1 is 180 minus 40 degree minus 28.8220. Okay. So it's end up that we have 111.1780, okay, degree right here. Then now, possible angle number 2, we have angle B sub 2 is 40 degree. And the angle C sub 1 is 180 minus 28.8220. Okay, so this is what we have. And then it is equal to 151.1780. Okay. So notice the sum of angle B and angle C to the triangle number 2, okay, is actually more than 180, isn't it? So if it is more than 180, meaning what? Angle A, this one should be C sub 2, okay? Angle A sub 2, angle A sub 2 must be negative because again, it is equal to 180 minus 40 minus 151.1780, right? And then it's turned out that we have a negative angle A. And of course, you know that it is impossible to have a negative angles. So in this case, meaning we have no triangle number 2 then, okay? So therefore, in this case, we have one triangles to this SSA, okay? Okay, so now, so now when you work on the homework assignment, okay? Okay. So, of course, make sure that you know that your 8.1, the section 8.1, you have two different homework is 8.1 and then also 8.1 applications. Okay, so you need to finish both of them. And then if you check it out, the homework assignment 8.1, okay, then you will see that to problem number 8. To this problem number 8 right here, then the problem will ask you to find the angle A sub 1 and also angle, angle B sub 1 and angle B sub 2. This is kind of like the idea that you have at SSA triangles, okay? So therefore, you may end up with 2 triangles then. Okay, so now, let us continue to see, to finish this now, okay? Okay, now, to this number 3, problem number 3 here, we have a communication tower, okay? It's located at the top of the hill, okay? And the angle of inclinations of the hill is 58 degree. And then a guide wire, okay, is to be attached. This is the guide wire that we have. Okay. Attach the top to the top of the tower and the ground that is 100 meters downhill from the base of the towers. Okay. And then to make this angle right here, alpha is actually that 12 degrees right here. Okay. Now you will see that when we have this type of problem, especially is application problem here. We have a real world that the tower is not, it's like a triangles, right? Okay. So in this case, it is really hard for us to, again, work it out the problems. So what do I need to do is I need to simplify the diagram that we have. Okay. So how do we actually do this? First of all, the tower, instead of using a triangles, you could actually using a straight line, okay, to actually to represent the tower. Okay. And then because it's sitting on the top of the hill, then you could actually using, okay, like triangles to work it out like the hills that we have. Okay. And connect with a guide wire, okay, attached here. Okay. Then one thing about this is, again, to this hill, what I would like to do is I would like to make this. Okay. Mhm. Just like this. Okay. And now I'm going to put it in the measurements. Okay. Now, first of all, you have to notice that this angle right here is a 90-degree angle. Okay. And the distance from the base of the tower to here is 100 meter. And then this angle right here is 58 degree, right? And of course, the last one, this angle right here is 12 degree. Okay. It seems that we have nothing, nothing else, okay? Okay. Then now, let us slowly work it out the problem. First of all, what I want to find is, I would like to find this, the cable, okay? The length of the cable. So then maybe let us do this. I would like to let X be the length of the cable then. Okay, this is what we want. And then now you will see that in order to find out this X, Y here, again, notice this, we have a triangle here, right? Okay. So in order to find this X, Y here, what we need to do is we need to find this angle. Okay. And in order to know this angle right here, or maybe one thing about this is if we know this angle, then using this angle right here, we will be able to find out this angle. Okay. Okay, so why do I need this angle? Because with this triangle right here, if I know this angle, I have this side. So I will be able to use law of sine to help me to set up the problem. Okay. Okay, so then now let's see. So we have this is 100 here. And then this angle right here is 12 degree. Okay. Okay. And now let us try to see if we can find this angle. Okay. Then now, if I know this angle is 58 degree, then of course I will be able to find this angle. Okay. So in this case, this angle, maybe let me call beta then. Okay. So the angle beta, basically it is equal to 90 degree minus 58 degree. Okay. So in this case, it will be 32 degree then. Okay. Again, because this is the right triangles, right? Then now, maybe we name this, okay, the gamma. Okay. So then in this case, you will see the sum of the angle on the line is 180. So therefore, the angle gamma is 180 minus 32 degree. Okay. So which is 148 degree then. Okay. Okay. Then now, of course, to this one here, okay, then maybe we call this theta now, right? So then I will be able to find the angle theta. Is actually, it will be 180 degree minus 148, and then minus the 12 degree. So in this case, I found out that the angle theta is 20 degree. Okay. Then now let's see how do we actually work it out the problem. Okay. So now we could use this angle theta 20 degree and this 100 to help me to set up the law of sine. Okay. And I have x over sine of the alpha. The gamma is 148 degree. Okay. Which is equal to 100 meter over sine of the theta, which is 20 degree. Okay. And I found out that the answer that I have is 154.9380 meter. Okay. So in this case, we could answer this. The length of the cable is about 155 meter then. Okay. Okay. So then I will stop the video here, and then my next video will talk about the law of cosines then. Okay. Thank you.